Well, good afternoon. This is Peter Moon with O2 Compost. Welcome to our webinar series on aerated static pile composting. I am the owner and principal engineer of O2 Compost, and I really appreciate your joining us today. As a starting point, I'll tell you a little bit about our company, and then we'll get right into the webinar itself. O2 Compost specializes in designing compost systems and operator training. All of our systems utilize the aerated static pile method of composting, also known as ASP composting. And we work with all varieties of organic waste and all scales of operation. Today's webinar is the first in a series of 10 webinars. Looking at the webinar series, my objective is to describe the ASP method of composting and to compare ASP composting to turned windrow composting, discussing the many advantages. Excuse me. We're going to focus on each of the ASP benefits. We're going to overview those today, but future webinars will take a look at each of those benefits in detail. This webinar series is intended for commercial scale operators who are currently using a turned windrow method, or for those folks who are interested in starting a new compost business. We're going to be addressing specific topics, and my goal is for each of the webinars to last 15 to 20 minutes so that it doesn't take a great deal of anyone's time. The objective is to watch the webinars in any order that you choose, first to last or in any order. Many of you will have specific topics that you're interested in. Maybe it's odor control or reducing the footprint of your system, and so you can work through them in any order that you choose. So let's get started. The objective of composting is to convert raw materials, raw feedstocks like what you see here, food waste out of a grocery store, into a high-quality soil amendment product that has strong market value. And we do this by using the aerated static pile method of composting. The photo you see here is a horse farm in Petaluma, 40 horses, manure, and they were able to develop a system that was extremely sustainable. This project took place 15 years ago. The topics we're going to be discussing in this webinar, the introduction, is to answer the question, what is ASP composting? The importance of aeration. We're going to take a look at the anatomy of an aerated static pile, the benefits of ASP composting, and again, each one of these benefits will be discussed in detail in future webinars. We're going to open it up to questions. I'm going to start with a series of questions that I quite frequently get, and then we'll answer questions that those who are attending live might be interested in answers to. What do we do to get started with a pilot project at your facility, and how to take action from today forward? So what is aerated static pile composting? With aerated static pile composting, we're constructing a compost pile over a network of aeration pipes, and we're inducing airflow into the pile using an electric blower that is operated by a timer. The timer may be set for 5 minutes every 20 minutes or 2 minutes every half hour, depending on a number of factors. But the idea is that we're cycling air into the pile 24 hours a day, 7 days a week. We do not turn the pile during the first 21 to 30 days, a period we refer to as the active phase of composting. And we can adjust the airflow to manage the pile temperatures and optimize the biology of the composting process. And finally, we operate the blower using either grid power or solar power. The next series of pictures are of different scales of operation, starting with our smallest scale, what we call a micro bin. These are 4 by 4 by 4 foot boxes, 2.5 cubic yards each, and these are excellent for prototyping different mixes. So if, let's say you're a yard waste compost facility, but you're interested in taking in food waste, this is an excellent way to test different recipes and different mixes before you go to a full-scale operation. This is a somewhat larger system, not portable like the micro bins, but rather built in. This is a horse farm in North Carolina. 3 bins all operated from the same blower with a series of valves to direct the airflow to the bin that we're currently composting. Similarly, a top-down system built in Massachusetts, again a horse farm, been operating for 8 to 10 years at this point. This is what we call a block bay aerated system. This is a high school in Southern California where the students are resident to the school. They each have their own horse, and they're composting manure and food waste out of the cafeteria. This is a solar operated system. Looking at a freestanding aerated static pile, this is a project in Pennsylvania, 4 pipes, and this is very, very similar to a prototype or a pilot scale project that you might construct at your facility. Working our way up in scale, this is an extended aerated static pile where we have 3 blower zones. Each blower feeding air into a manifold and 6 lateral pipes. And I'm going to talk about the type of pipe here in a moment. So the importance of aeration. By inducing airflow into the compost pile, we're able to maintain aerobic conditions throughout or without turning the pile. This is saving us a tremendous amount of time and effort. We're able to optimize the biology of the composting process and manage pile temperatures to within a desired range to really optimize the composting process. Reduce offensive odors and neighbor complaints, greatly expedite the rate of composting, and produce a high-quality compost product in less time and typically with higher value. Looking at the geometry of an aerated static pile, in this example, we have the pile width, which can vary greatly. Pile height, typically 6 to 12 feet. Pipe spacing is about 5 feet. The pile length, we try to limit to 75 to 80 feet to make sure that we're getting uniform airflow over the full length of that pipe. And generally, we consider the side slopes of a freestanding pile to be about 1:1. Looking down on this same pile, we see the inner rectangle. This represents the top of the pile. The outer rectangle is the base of the pile, or the toe, where it comes in contact with the ground. And then in between is our side slopes. This red line represents a cross-sectional view of the pile. Imagine that we've taken a slice and moved part of that pile away. So there are several component parts, beginning with the pipes themselves. For a pilot project, we typically will use thin wall, perforated and solid pipe, anything that you can get, 4-inch material that you can get at Home Depot or your local hardware store. When we go to a full-scale long-term operation, we recommend a thick-wall HDPE pipe. It's much more durable and it will last for years and years and years. Alternative to pipe-on-grade systems will be trenches built into the concrete slab. Now, there are many advantages of trenches. In particular, you're not having to handle pipe, but we need to consider in the design of this system that they need to provide both aeration and drainage should any excess water come out of that mix of materials. These are not maintenance free. They do need to be cleaned out between pile intervals, and the trenches themselves need to be cleaned every 6 months or thereabouts. So looking at a pipe-on-grade system, we want to place an aeration plenum layer over the top of those pipes, typically consisting of wood chips or screen overs. This serves as a means of distributing airflow uniformly across the base of the pile. Over the top of the plenum layer, we place our compost mix. We'll be discussing this in much greater detail in future webinars, but in short, there are 3 component parameters that we're looking at. The first being nutrient balance, or what is often thought of as the carbon to nitrogen ratio of the mix. The second is the bulk density of the mix, which is an indirect measure of the porosity and our ability to push air up through that pile. And then the third parameter, moisture content, in my opinion is the most critical of the three. We want a moisture content of about 60 to 65% in the initial mix, because we are going to be losing moisture during that first 30 days, and we want to have sufficient moisture for the composting process to continue without stalling out. Over the top of the mix, we place a biofilter cover layer. Generally, I recommend to use unscreened compost. Ultimately, when we break that pile down, we're going to be mixing that layer in with the other composted material, and there's really no point in screening it and going to the cost and effort of doing that prior to using it as a biofilter cover. Taking a closer look at the biofilter cover, there's 6 important reasons for this layer. First, it serves as an insulating layer so that all of the materials in that raw mix reach pile temperatures sufficient to destroy parasites, pathogens, and weed seeds. General parameters are 131 degrees Fahrenheit for a minimum of 3 days, and this goes all the way to the outer surface of that initial mix of materials. This is referred to as a process to further reduce pathogens, or PFRP. Equally important to that is that the layer serves as for odor control, for biofiltration. Any of the volatile organic compounds or ammonia or greenhouse gases that are wanting to escape off of that raw mix will get absorbed in that 1-foot layer of finished compost, and they will get treated in situ by the microorganisms that reside in that layer. And the net result is a very mild, fragrant, organic odor that comes off of the pile, something that's not strong nor offensive to neighbors. The third reason for the layer is nutrient retention. For example, ammonia, which is a nitrogenous gas, gets absorbed in that layer. It's very efficient. It gets treated, and that nitrogen is retained in the finished product, which helps product value. It also serves as vector barriers, so if flies are a problem, or birds, rodents, even wildlife, larger wildlife. We've had instances where bears and coyotes have expressed an interest in what's in that pile. When they dig into that pile, they will find very quickly this sucker is hot, and I can't go any further. It also helps with moisture retention. I mentioned earlier that moisture management of a compost pile is really critical to maintaining the biologic process throughout that active phase of composting. And ultimately, that outer layer of finished compost helps to improve the aesthetics. There's a saying in the composting industry, people smell with their eyes. If they're looking at an ugly mess, they will sense that and experience that as odor. So we want to have a nice, tidy site, and this helps tremendously in that regard. This is a picture of a partially constructed pile from one of our hands-on workshops here in Snohomish, Washington. You see the blower and timer, a simple manifold of solid pipe. These are lateral pipes. The perforated zone is covered by wood chip plenum material. And then the green grass here and shredded yard waste represents the mix itself. Because we're in the process of constructing the pile, there is no cover layer at this point in time. Now, using that same example, this being the aerated static pile, we can add pipe and plenum material and additional mix over the top and progressively make the pile wider and wider. This is referred to as an extended aerated static pile. As we're building the pile, we are also extending the cover, because obviously our reach is only limited with the loader or excavator that we're using to apply that material. This is an example of a facility in California, a grape pumice compost facility. Each of these piles measures 80 feet in width, about 550 feet in length. They're about 12 feet tall when they're first constructed, and there are 10 blower zones in each of these piles. Each pile has about 25,000 cubic yards in it. So, what are the benefits of aerated static pile composting? With ASP, we're able to reduce the footprint of the active compost pad. Typically, if you're using a windrow turner, we can reduce it anywhere from 3 to 6 times, depending on the type of equipment you're using. By doing that, we're also able to increase the site capacity as well as the throughput on a given facility. We're able to resolve off-site odor impacts and neighbor complaints, reduce the cost of processing because we're using less equipment, labor, and fuel during the active phase of composting. We're able to process more challenging feedstocks. A lot of the facilities we work with have been traditionally yard waste systems, but now they're taking in food waste or biosolids or other more challenging and odorous feedstocks, and we're able to manage those odors quite effectively. We're able to improve product quality and increase the selling price ultimately of the finished compost. So let's take a look at some of the frequently asked questions that we get, especially in the training classes that I offer. How do we get the pipe out from beneath the pile? Well, with the thin wall, it's usually considered to be sacrificial, but when we try to recover it, we can scalp the pile and then do some hand labor to dig it out and pull it out from the pile. Thin wall pile, because of the heat of the system, will tend to become oval over time, and you may get 1 or 2, maybe 3 uses out of it before it needs to be replaced. For a long-term permanent systems with pipe on grade, we recommend using thick wall HDPE pipe, high density polyethylene pipe. And with that, you can literally chain up to it with your equipment and pull it out of the pile, much like you would pull a cork out of a bottle. What are the pros and cons for using aeration trenches? Well, certainly not having to deal with pipe after the fact is a nice thing, because that is something you have to handle. However, as I mentioned earlier, they do serve both to deliver air into the system and drains, and so that drainage system needs to be designed and constructed and maintained. That's not an easy thing to do. What is positive versus negative aeration? This is something I haven't really addressed yet, but positive aeration is when we are pushing air into the pile. I subscribe to positive aeration for a number of reasons I'll mention here shortly. Negative aeration is when we're pulling air through the pile. With positive aeration, it's fairly simple. We're just pushing air up through, and we size the equipment to manage the density of the material and the aeration requirements of that pile. With negative aeration, you're pulling air from the pile, and that airstream is going to be extremely hot, whatever the pile is, 150, 160 degrees perhaps. It's also going to be saturated with moisture, such that when that airstream begins to cool to ambient temperatures, a great deal of water or condensate will fall out of the airstream and end up in the pipe, in the discharge pipe, and that needs to be managed. That condensate tends to be odorous, and it tends to have an extremely low pH. It's very acidic, so it's hard on equipment. For that reason, we need to have specialized equipment, stainless steel perhaps, or fiberglass fiberglass reinforced plastic equipment, and it needs to be larger because it's more difficult to pull air through a pile than it is to push air through a pile. What size blower do you use? This is a great question. I get it all the time. And the one answer to this question, and it's true of most questions in the composting industry, is it depends. It depends on a number of factors: the size of the pile, the energy in the pile, the bulk density, and the difficulty of pushing air through the pile. And so this is something that we would help you to determine in the pilot phase of your project. If the ASP method is so effective, why isn't everyone already composting this way? This is a good question, and quite honestly not one that I can answer very easily. ASP composting was first developed in the early 1970s and in Beltsville, Maryland, and it's in wide use in many, many facilities, but For some reason, the majority of composting operations still subscribe to the Turn-Windrow method. And these are folks that we work with quite often for a number of reasons, odor, capacity, and so forth, and help them convert over to an ASP system. So at this point, what I'd like to do is open it to any questions that we might have with the group. And I'll ask my assistant Chris to join me at this point to see if we have any questions. Chris?
Hey there. Excuse me. Go ahead and open it up for questions here.
Are there any questions on the tab? I've neglected to mention people could add questions in their panel there. I'm assuming there aren't any questions at this point, so let's go ahead and move forward. If you have any questions, feel free to contact us and we'll be happy to answer them either by email or over the telephone. So looking at future webinars, the first one, which we've just completed, Introduction and Overview, we looked at several of the different topics that we're going to be addressing in future webinars. In the second webinar, we're going to take a very close look at increasing site capacity. The third, resolving off-site odor impacts, reducing costs, increasing profits. The fifth webinar will look directly at how do you conduct a pilot project and why do you want to do that. We will also take a virtual tour of aerated static pile compost systems. Many of these I have designed, many others are proprietary systems that we'll take a look at that are scattered around the country. We'll look at the secret of aerated composting. This is where we really start talking about the inner workings and the science and engineering of the composting process, as well as the keys to aeration and the biology of composting. And then ultimately we're going to look at aerated static pile composting as a manufacturing process. In our training programs, we teach you the art and science of composting. And once you understand those basic principles, then the natural extension of that is materials handling and really making the system efficient so that you're minimizing the number of times you handle your materials. So, taking action. What I recommend is watching any of our additional webinars that will be posted on our website. Visit our website, www.o2compost.com. From there, you can submit a Contact Us form, and we'd be happy to schedule a time for a free half-hour consultation with you to discuss your situation and maybe some of the challenges that you're facing or what you're planning on doing, especially for those who are thinking about starting a new composting business. If you're interested in pursuing a working relationship, we will send you a proposal for our ASP pilot project. And when you've had a chance to review that, we'll contact you again and you can make a go, no-go decision. There's no pressure, there's no time limit. We're happy to help you whenever you're ready to get started. And we're looking for opportunities to help folks like yourself start up your own ASP system. So that completes our first webinar. I really appreciate your joining us today. And if you have any questions, again, you can contact us at www.o2compost.com or by calling us at 360-568-8085. Thanks very much.